Profile machining. Profile machining is frequently used for engraving, and to engrave the three letters CNC, and to engrave it at 200 millimeters length and 100 millimeters width. Firstly, select the text, go to transform, and scale it. Untick the keep XY ratio and enter X at 200 and Y at 100. Click OK. Now click Toolpath, Profile Machining. You can select your tool from either the submenu here or the tool library. We are going to use the end mill diameter 3.175 and height at 22. If you need to add a tool, you can click Add. There are three positions for you to select: onside, outside, and inside. Onside, and the two center axis along the drawing will be cut. Outside will cut the outer contour of the drawing, and inside will cut the inner contour of the drawing. We'll use outside. Bridging. To prevent the machine object from moving, which may cause the object to be destroyed or maybe cause machining errors, the machined object should not be completely separated from the material until the machining is finished. After the machining, the object can be separated from the material by hand. Plunge. The tool will enter the material but not make contact with the material in a vertical direction. Instead, it will enter on a slant so that the tool will not be damaged while entering the material. This is also to ensure that there are no marks or scars left on the surface of the material. There are three ways to plunge: ramp, pecking plunge, and lead in and out. Ramp is to plunge in a certain angle to prevent the tool from breaking from the force while entering the material. Pecking plunge will cause the tool to enter the material at a certain depth and then drive up to a certain height, and will repeat the process when cutting material until a certain depth is reached. Pecking plunge will prevent the tool from breaking, especially when cutting hard materials. Lead in and out. When using lead in and out, the tool goes into a certain depth of the material, then cuts into the active area. There are two ways it will cut into the material: arc and line. In order to avoid incision leaving traces, we usually use ramp down at 45 degrees. Trochoidal. This option is specifically designed for brittle materials such as glass or granite, or extremely hard materials that will generate a lot of heat upon cutting. The trochoidal toolpath will produce a circular toolpath at high speeds with low load on the tool, and therefore reducing the heat while providing a longer tool life. There are two types of trochoidal rotation: half circle and full circle. And specify the height of the circle, the space between the rotations. The full circle motion is ideal for high-speed machining, while the half circle may be more appropriate for traditional cutting and at lower speeds. The height of the circle should be less than the tool diameter. Now, the cut parameters. Total depth is how deep the tool will enter the material. If your tool cannot reach this depth, you can choose pecking plunge. Sequence is to create the shortest toolpath. You can also choose to machine from the X direction first or from the Y direction first. Multilayer is when the depth of material is greater than the tool, or because the material is too hard and needs to machine layer by layer. You can use this function and select the depth per layer. Cut direction will specify which direction the material cut direction will specify which direction the material will be machined. Clockwise can be used for high density materials such as brass, and anti-clockwise should be used for low density materials such as PVC boards. Now click OK, and then toolpath output. Now the parameters here, you can generally leave the processor file at general CNC. And to pick the origin point, there are 3 ways to choose the origin point. Custom, and you can choose the point of origin yourself. Same as before, it will remember the previous path position and restart. And based on point A, B, C, D, and E, you can see that it starts from either the bottom left, bottom right, top left, or the center, based on their corresponding letters. Now, the save height is the distance between the tool and the material surface when the tool is traveling above the material. The speed down height is the distance between the material surface and the position tool as it begins to decelerate. Now, save this toolpath. And you can choose to order your toolpaths by choosing up and down. And there will be a delete option here also, but that is when you have more than one toolpath. Now save. And that is the end of this tutorial. Thank you.